Okay, so the motion of the particle is described with, so the particle is moving along a curve, and you can describe the movement of the particle using r and theta. So like any other problem in this chapter, first you draw a free body diagram. Show the coordinate axis. In this case, the coordinate axes are UR and U theta. U theta is the direction which, so I'm assuming that the particle is moving this way. So theta is actually increasing upwards. So U theta is going to be upwards.
So it'll show that on the arrow, right?
Yes. Yeah. Well, usually may not show. Sometimes when we assume that counterclockwise is positive, so that way it is counterclockwise, unless you're told clockwise is positive. So once I draw the axis, I can then draw the forces Fr, F theta, and then write the equations of motion EOM. Fr is all the forces in the radial direction, so you need to sum all the forces. So gravity could be a force, and you need to resolve it in the r direction, and you see when we do the problem. So summation of forces, and then summation of forces in the theta direction should be mass times acceleration the theta direction, and that's a formula we've done in the past. Is it working? It's fine if you fix it afterwards. I just didn't, it was not an emergency, so I sent an email, I didn't call.
Okay.
But
What time is your class then?
at 10:50.
10:50. Okay, I'll come back a little bit after because there's more to it.
That's fine. That's fine. Yeah. Thanks a lot. Okay, now here's one very important thing, which is UR U theta is not the same as UT UN. UT UN is anti-coordinates. We did it last time, and the common mistake people make is assume that theta, U theta, which is in the theta direction, is the same as UT, which is the tangential force. So that's not true. I'm going to actually draw. So we'll see there'll be problems where the forces can be resolved in the UN direction, but the coordinates are given in terms of r and theta, in which case you'll have to actually find how UR and U theta is related to UR UN, and then use that in order to solve for forces in r and theta direction. So that'll be clear when I do problems, but here is the theory behind it. So what I'm trying to get to is page. Okay, so the particle is again moving on the curve described by r theta. Okay, and one question which is a common question is find the forces in the tangential direction, find the force in normal direction. So if I draw a tangent over here, that's not the same as this is the tangent, or this is the same as UT direction, but this is U theta. It's always 90 degrees to R. So UT and U theta need not be in the same direction. For a circle, things moving in circle, ut is the same as u theta, but in general it's not true. Okay, so don't assume that. Very common mistake. So what we do is we can actually find how we would extend this. This is the UR direction, and then UN is going to be normal to UT. This is UN, or in other words, this is UN. UN, and then if we draw UR like this, okay, and this is psi, and there's a formula for psi. Just check one thing. I'm just trying to check if this is right. Once I made a mistake with this notation. I just want to check the book quickly. So psi is the angle between, my bad, so it's between R and T. So this is not right. Slight change. This shouldn't be the angle, but this is the angle. This is psi. So you got to make that change. So psi is the angle between the tangent and the radial component. Okay, but the formula is right. Tan psi is R divided by dr d theta. Okay, so when will this be useful? You'll see that you'll be given the curve in terms of r theta, but you'll be asked to find ft and fl, in which case you'll have to use this, and it'll be clear when I solve problems. I just changed that, the psi. Okay, so let's see how this is useful and solve problems. That's the best way I can illustrate that formula. So if the arm OA rotates with a constant clockwise angular velocity of theta dot equals 1.5 radians per second, determine the force arm OA exerts on the smooth 4-pound cylinder B when theta is 45 degrees. So this is 45 degrees. Okay, so the first thing to note is that you're given the r theta, right? You're shown r theta, so it's probably a problem using polar coordinates. Since you're asked to find the force, this is a problem involving questions of motion, so we have to draw a free body diagram before we can solve for the forces. So free body diagram of the cylinder B. Okay, I need to show the forces. This is in the horizontal plane. So imagine this setup was actually in the plane of the paper. So gravity does not affect the motion of the system. So gravity will not show up as a force. Okay, so how do we draw forces? When you draw forces, think of all the surfaces where the cylinder is contacting. So the cylinder contacts the vertical surface. So since it's a circle, the force exerted by the wall, the vertical wall, is going to be normal, right? So it's going to be a horizontal force. So let me show that as this, and let me call that, let's say N1. Okay, that's an unknown. The other object which the cylinder contacts is the lever arm, which is turning clockwise direction. Okay? And that force, again, since this is a flat surface and it's a circular block, cylindrical block, the force is always going to be at right angles to the surface. Okay, so right angles to OA. So if I draw the force, I have to draw it at right angles. So I know the direction of the force. What I do not know is what the value of N2 or N1 is, and that's what I'll get when I do solve for those forces in the equations of motion. Okay, mg, as I said, will not show up because gravity is acting. This system is in the horizontal plane, and gravity is acting that way. So gravity has no effect does not affect the movement in the horizontal plane. Okay, so we got that. We have to also define angles so that we can then resolve forces. In this case, we want to stick with r theta coordinates. So I'm going to draw u theta. Don't mind. Yeah.
How do you know that it's acting on the horizontal plane?
Because you're given, assume g is 0.
Okay, so
Okay. Yeah, so if you're given a value for g, then it is in the vertical plane, and then you have it makes the problem solution a little bit more complicated, not too much though. Okay, so now let's draw the r theta coordinates. Remember that the r coordinate is going to be along this, right? UR, and u theta is going to be in the direction which the cylinder block is increasing, so that's going to be the direction. So I'm going to draw UR like so, u theta. Okay, and in fact you'll notice that the normal force N2 is along u theta, right? Because that is the line which is at 90 degrees to the link or the lever arm. Okay, so this is UR. This angle is going to be theta, as you can see over here. And so once we have set up the forces, the coordinate axis and theta, we are ready to write the equations of motion. Okay, I'm going to use polar coordinates because r theta is given. Fr equals m r double dot minus r theta dot square. So that's summation of all forces in the r direction, in this direction. So you can see that the only force acting in the r direction is going to be N1 resolved in the r direction. So N1 cosine theta is the magnitude of the force. When you resolve it, it points that direction, which is positive UR, so it's positive, equals mass times r double dot minus r theta dot square. The next equation is F theta is m times r theta double dot plus r 2r dot theta dot. Okay, let's write the forces in the theta direction, which is that direction. Okay, N2 acts in u theta direction. It's positive because it's along in the direction which u theta is pointing. So N2 is positive, and then we need to resolve n1 in the direction of u theta. When I do that, I get n1 sine theta, and the direction is downward, so u theta is upward, so the sign is going to be negative. So negative n1 sine theta equals okay. So what are the unknowns? The unknowns are force which arm OA exerts on the smooth cylinder, so that's going to be N2, right? So N2 is unknown. In this equation, in fact, N1 is also unknown. I don't need it, I'm not being asked to solve for it, but that's an unknown in that equation. That's an unknown. So as long as I can get everything else in those two equations, that's 1 and 2. So I have two equations. If I can solve for other things, r dot, and so on, then I can actually find n1 and n2. So let me try to find r, its derivatives, and theta and its derivatives. Okay, so what's given? We're given theta is 45 degrees. We're given that theta dot equals 1.5. And you also told that constant clockwise angular velocity, which implies that theta double dot or acceleration is 0. Okay, so that's theta. Now, how can I find r dot, r double dot? I've not been given a formula for RE in the problem formulation. How can I find R? What's R? What's that? It's a radius, but is there a relation between R and theta? S equals R theta. Yeah, that will be an arc length. If this was going in a circle, then it will give you, S is the arc length. So S would be an unknown, and really it's not related in this problem because the ball is actually moving up and down. R gives the location of the ball from the center O. So can you find the way in which R is changing as a function of, say, theta? Can you relate it using this 4? So R cosine theta is 4, right? So R cosine theta is 4. And that's always true, right? Just imagine going down. R cosine theta will still be 4, but that 4 doesn't change. So R equals 4 secant theta. Okay, now we all set to find R dot, which is 4. The derivative of secant is secant times tan times, remember I'm doing a time derivative, so I need to keep the theta dot, and then R double dot equals, this is going to be pretty messy, let me write it here. So to do the derivative, the second derivative, what I do is have 3 terms there, secant tan theta dot. I keep 2 of those constant, differentiate the third, and I keep cycling till I get 3 expressions. So keep secant tan constant, differentiate theta double dot, then keep secant and theta dot fixed, and differentiate tan, so secant square theta dot, and then keep 4 tan theta dot fixed, and then differentiate secant, so you'll get secant times tan. Then I'm forgetting a theta dot here. Should be theta dot square, right? Because there's a theta dot here from here, and then there's another theta dot coming from the fact that I differentiated.
Sorry,
Yeah.
I just want to let you know that the room isn't reinforced with the podium microphone. So if you want to everybody hear you, or I would need to bring a the speaker on there.
Oh, okay.
Is that something you want me to set up for you?
No, it's okay. I think, do you guys in the last row hear me loud enough?
You don't need a speaker to hear him?
No.
Y'all can hear him just fine?
I'm fine. I'm just. It was not.
Yeah, that one right there only works for video conferencing for a
I see. I thought it was just broken. That's why I
Oh, no, yeah.
that's fine. Yeah, I'm fine.
Thank you.
Thanks. Yeah.
Professor,
Yeah.
the lecture is given at the back of the class.
Speak louder. Okay. Is this loud enough? Yeah. Question. Yeah, I'm going to write it down again. Hold on. If I can actually get a lapel mic, that's easiest than him getting the cart and. Okay, so this is what I want to read. Okay, am I loud now? Okay, this is really hard to keep this pitch and. Let me ask for a lapel mic next time. That's what I'll do. Okay, so in this expression, all I do is I put theta equals 45, I put theta dot equals 1.5, and theta double dot equals 0. So I can find r dot, r double dot. And once I get that, I put that in equation 1 and 2, the right hand side, and I can solve for n1 and n2. So if you put in the values, you get r equals 5.657, r dot equals 8.485, and then r double dot equals 38.18. Okay, and then solving for n1 gives me 8.472 lb, and n2 is 12 lb. Any questions on this? Okay, so what I'm going to do is I don't think I have time to do a question today. What I'll do is I'll give you attendance credit. Let me, if you have an eye clicker, okay, choose any option. And all answers are right. A, B, C, D, or E. So I'm just trying to take attendance. So you can poll any of the answers, A through E. So this is, I'm just giving you credit for your quiz. Just poll any answer, A through E. And a bunch of people who have not responded, please try to respond quickly and go on.
Responding to my class.
Not working? Restart it.
No.
Okay. Okay, so here is an example of a problem where the tan psi comes into picture. Okay, the collar of mass 2 kilograms and travels along a smooth horizontal rod. So it's a smooth horizontal rod, which means the friction force is negligible. Defined by the spiral r equals e raised to theta. Determine the tangential force and the normal force acting on the collar when theta is 45 degrees if the force F maintains a constant angular motion of theta dot equals 2 radians per second. Okay, so let's draw the free body diagram because you asked to find forces, so you have to apply show the free body diagram before you can write the equations. So free body diagram of the particle, it's acted upon by the force F, which is a no-brainer. It just is acting this way, which is actually tangential, right? You're given that's a tangential force. So what it means is that if you draw the curve like this, which is r equals e raised to theta, then that force at that point is going to be at a tangent to that curve. Okay, you are also asked to find the normal force, which I'll draw this way. Okay, both those forces are unknown. Okay, I'm also told you that gravity is 0, which again means that this system contraction is in the horizontal plane and gravity has no role to play. So mg will not be a force, but if I had given you gravity and this was in the vertical plane, then you should show mg like that, right? Okay, so those are only two forces, no friction. Now here's the thing which is sort of hard about this particular problem. The forces F and N are along UT and UN. Okay, this is UT, UN. However, you're given the curve in polar coordinates. So F and N are in UT, UN, while the curve is given r theta. So when you have this issue where there are two coordinates used, you want to solve the problem in r theta coordinates because we can relate those unit vectors UT, UN with UR, U theta, and that was all about the formula I talked about, tan psi. So what I'm going to do is, let me draw r and theta. So UR is going to be this is going to be U theta, and this is going to be UR. Okay. It's easier if I draw it like this, UN, UT. So you can see now that UR and UN, so UR and UN are not along the same direction, so is U theta and UT. They are actually at an angle. Okay, when that happens, you can find the relation between those two frames if you remember the expression I wrote down earlier. It states that psi equals r divided by dr d theta. where psi is the angle between R and N. Sorry, R and T. So R and T, which is this. Okay, so we have that. Let's start writing the equations of motion. So again, as I said, you want to write equations in FR R theta coordinates because you know the curve in R theta coordinates. So FR equals M R double dot minus R theta dot square. So all the forces in the R direction, which is this direction. So F, the force, this angle is going to be 90 minus psi, right? Because F makes an angle of 90 degrees with N. So now I can write forces in the R direction, N times cosine of 90 minus psi is going to be in the R direction. So cosine 90 minus psi with a positive sign. Then for F, it's going to be F cosine of psi with a positive sign, right? F cosine psi is going to be, that's not right. Yeah, that's my bad. That is right. F cosine psi is going to be along UR, right? Equals mass times R double dot minus R theta dot squared. And then let's write the formula for F theta equals mass times R theta double dot plus 2 R dot theta dot. Okay, so forces in the theta direction, F, if I take F sine psi, then I would get one force in the U theta direction, contribution due to F, and for N it's going to be N sine of 90 minus psi. N sine 90 minus psi, but it's pointing in the direction which is opposite to my assumed direction of theta, so it's going to be negative. Okay, so let's write the unknowns. They are N and F. I need to find everything else, and I can do that. So let's find it one at a time. R equals e raised to theta. So R dot equals e raised to theta times theta dot, and R double dot equals, when you have uv, you need to keep one constant, differentiate the second term. So theta double dot plus e theta theta dot squared, right? And then for psi, that's simply R divided by dr d theta, which is R is e raised to theta. When you take the derivative of R with respect to theta, not t, but theta, it's going to be e raised to theta. So that is 1. So psi is 45 degrees. So since R is e raised to theta, dr d theta is simply e raised to theta. And that's what I put over here. Right? Derivative of e raised to theta is the same thing. Okay. So what remains is I just need to put in the values for theta. Well, let me write it down. Theta is it given for, I think, 45. Theta dot is given as 2, and it's constant, so theta double dot is 0. So all I need to do is take these values for R dot, R double dot, which I wrote down, psi, put in equations 1 and 2, and solve for N and F. Okay, I don't think I have the right answer here because I messed up an angle. So I'm going to solve it a little later and put the final answers down there. But this is a problem where there's a mixture, and I've seen that when we put this question in the exam, students get confused and they get it wrong. And there are only so many questions of this kind. This is an important question. If it doesn't show up in the term exams, very likely to show up in the finals. So favorite question. Not this one, mind you, related to the psi angle.